Give me one moment. Okay, so this is going to be more like what your FRQ will look like next Tuesday. So we'll work through one version of it, and then your homework is to, I mean, if we get to some of the homework problems, that's great, but our goal is to get through as much as between 7 and 10 as possible, and whatever we don't finish will be your homework. Okay, so this is let f and f prime be differentiable functions. The table gives values of f and its derivative, f prime, at the selected values of x. So we have some information about f, we have some information about f prime, the slope at that particular point. We have another function, g of x, that's given here. We have h of x. H of x is related to integral of j of t. So we have a couple of things going on here. Okay, so let's do some review here. It says, is there a value of c between 1 and 5 such that f double prime of c is equal to -3/4? Provide an explanation for your answer. So you guys don't have to write this down, but this is basically asking, does the slope of f prime equal to -3/4? Okay, and this should remind us of something that we've seen in the past, which is mean value theorem. So let me kind of remind us how we can adapt mean value theorem here. So mean value theorem says, if I have a function that's a smooth curve, and the slope between the endpoints is some value, could be 1/2, could be 1/3, could be 5 or 6, could be a -2. We know that somewhere between, that graph is going to experience that exact same slope, right? Somewhere along the curve, at least once. Okay, so here's a formula from MBT. The slope between the endpoints, which is f of b minus f of a, is guaranteed. That slope between the endpoints is guaranteed to show up somewhere along the curve. And if we set them equal to each other, we can find the location of that particular slope behavior. So for instance, if there's a slope of 2 between these two endpoints, then we can use f prime to figure out the location where that slope of 2 is going to exist. So if we want to adapt mean value theorem, we can do this for other derivatives as well. So if I want to guarantee f double prime of c, guess what we can do? Find the slope of the first derivative. Right? And this also works, right? Because we can have the same graph and call this graph f prime. So the order pair at the f prime level is guaranteed, or the slope at the f prime level is guaranteed, where the slope of f prime is going to, so if the order pair at the f prime level is giving us a slope of 5, then we know that the f double prime must be equal to 5 as well, right? We're just basically taking, calling this the f prime graph instead of f of x graph. It's still the same relationship. It's just one derivative down. Okay, so if we take that into account here, is there a value between 1 and 5 such that f double prime of c is equal to -3/4? We can basically follow this formula. So what do you think our a and b values are in this problem? Yeah, our interval, right? Interval is just 1 and 5. So can we show that the slope between the endpoints at the f prime level is equal to -3/4? If there is, then we can say by mean value theorem, this is going to we can guarantee this value of -3/4. So f prime of 5 minus f prime of 1 divided by 5 minus 1. All right, what's the value of f prime of 5?
-2.
Okay, -2. Just pull it from the table. Minus, what's f prime of 1? It's 1. Okay. What is that equal to? Mm-hmm. So -3 over what? 4. Yeah. So we can guarantee it, right? The slope between the endpoints at the f prime level is equal to -3/4. So we know that there must be a slope that's going to be exactly -3/4. So we can say by mean value theorem, since f prime is continuous, and differentiable, so just as a reminder of mean value theorem, continuous with closed brackets, differentiable on the open parentheses, on the open interval. Okay, any questions there? So we're just applying mean value theorem, but doing it one level down, but the relationship is still the same. It's just that now we're looking at trying to guarantee a slope on the f prime graph rather than the slope on the f of x graph. Okay, part B. Let k be the function defined by k of x equals f of j of x. Write an equation for the line tangent to the graph of k at x equals 2. So if I want to write the tangent line equation, what information do we need? We need two things. What do we need? Point and slope. Yeah. So let's find the point first. We can find the slope. From the slope, for the slope, we can get it from the derivative. Let's find the point first. That might be a little bit easier. So we want to find k of 2. We know the x value is 2. So I'm just going to put it into the formula here. K of 2 is defined as f of j of x. So f of j of 2. So we got composite function here. What can we do first? We should find what first? So what could we pull first? How would you start this? Yeah, find j of 2, right? So j of 2, we have our j graph here. So j of 2 is equal to what? -1. Okay. So replace the j of 2 with -1. So that becomes f of -1. And what's f of -1? 4. Okay. So we have our order pair. 2, 4. Okay. So we'll come back to that when we need it. 2. Yes.
Like, where did you get f of? How do you see where f of -1 is on the graph?
It wasn't on the graph. It's on the table of values here.
Like which spot? Like which one do you look?
This is the f prime. We're looking at so this is f of -1 will be 4. F of 2 will be -1. F of 4 will be -2.
I know what J is.
J of 2, I just found the x value here. It's just the order pair. When the x value is 2, my y value is -1. Okay, everybody good so far? Order pair. So now if I want to find the derivative, or find the slope, I need to get to the derivative. To get to the derivative, what do you think we have to go through here? What rule does that remind you of? Yeah. So if you look in the back here, I have a formula sheet. Now, this formula sheet is just for your reference here. It won't be provided for you on any assessments. But if you look on the back here, chain rule says this. Chain rule says, if I have a function within a function, I take the outside function's derivative, then multiply by the inside function's derivative. So that's the form for chain rule. So what would the outside function's derivative look like? So f of j of x becomes what? F. Yeah, f. So outside's derivative comes first, and then the inside stays intact times what? J prime. So now that we have the calculus taken care of, we can plug 2 in to get the slope. Okay, so one thing at a time, right? We can't do all this in one go. What do you think is an easy thing that we can find first? Yeah, good. J prime 2, we can find that easily. What else is easy to find? Yeah, so this piece, we can replace that with a number, and then we can figure out the rest of it, right? But yeah, we can find j of 2. We can also find j prime of 2. Okay, so what's j of 2? -1. Okay, what's j prime of 2? What do you think j prime of 2 is asking for us to pull from the j graph? The what? Slope. Yeah. So what's the slope of this line? -2, right? So I go down 2 over 1, right? Down 2 over 1. Yeah, so -2. Yeah. So f prime of, we know j of 2 is -1, times j prime of 2, which we said was -2. So we're almost there. We still have, we found this piece that we replaced j of 2 with -1. We actually found j prime of 2, but there's still this one piece that's still missing. So that's f prime of -1. Okay, what's f prime of -1? Yeah, -3. So my overall slope is what? 6. But now that I have order pair and slope, I can put it into point slope form. Okay, so I like this problem because we're able to review chain rule, review how to work a chain rule problem when it's in function notation, and also practice tangent line equation. I mean, you're guaranteed to ask, they're going to ask you how to find tangent line equation in one form or another. So I want to keep this fresh in our minds. That tangent line equation, all you need to find order pair and find slope, but depending on what's given to you, sometimes the process may look a little different. Okay, any questions here?
Whenever you find a tangent line equation, it's the same thing as point slope form.
Yeah. Technically, you could do other forms as well, but I like point slope form because it's the most efficient one. It can get you to the version of your answer the fastest. I mean, there's also slope intercept form and standard form, but those take additional steps. Yeah. Part C, find the slope of the tangent line to the graph of g at x equals pi. So now we're not asked for the tangent line equation. Now she's asking for the slope. So we'll find the derivative, plug in the x value, get the slope, and that's all we need. So let's look at the graph of g here. So graph of g is here. So this one is not in function notation. We can actually find the derivative here. Do you guys remember what is the sine? What's sine's derivative? Good. Cosine of u times u prime. What's e to the u's derivative? Yeah. And then cosine's derivative. Yeah, so this is this has a little more going on. This is kind of like more of a nested chain rule. But yeah, we're going to go through each derivative. Once we get the derivative, we'll plug in pi, and then we'll try to get it down to a numeric answer. Okay. So let me write everything out here. So g of x is equal to all right, so g prime sine of u, you guys said it, cosine of u times u prime. Okay. And the derivative for e to the u is e to the u times u prime. And u prime is whatever the exponent's derivative, right? And we said the cosine's derivative is negative sine of u g prime. Okay, so now we can replace every x with what? Pi. I'm going to bring the 2 sine x in front, so 2 sine of 2 pi e to the cosine of 2 pi. So cosine of 3 pi, if you don't recognize 3 pi, you can always subtract 2 pi from it to get something that, you can always add or subtract 2 pi, get a coterminal angle and make it more familiar. So cosine 3 pi is same thing as cosine of what? Cosine of pi. Cosine of pi is negative 1. And then sine of 2 pi, what's sine of 2 pi? 0. Yeah, so anything times 0 is just going to be 0. This will also wipe this out, but technically it's e to the first power. Because cosine of 2 pi is cosine of, same thing as cosine of 0. Cosine of 0 is 1. E to the 0. E to the 1 is 1. But it's multiplied by 0, so all this is going to wipe out. So my slope is just going to reduce to just what? Negative 3, yeah. Hey, part D, find h of 4. So let's look at how h is defined. So h is defined here. So let me write the definition out and we can see what we can do with that. So here's h of x. So h is basically asking for the area under the j graph. So if I want to find h of 4, replace the x with what? 4. Now I had to put the 4 up here because that's where the definition is telling us to put it. But if we want to read the graph, what will we prefer to do? Flip it, right? So if I flip it, gotta pull a negative out, yeah. Okay, so from 4 to 6, let's see what that looks like. What's the area of this triangle here? Okay. 1/2 base times height. It's the shape of a triangle here. Yeah, 1/2 2 times 3, just be 3. Right, so h of 4 is just what? Negative 3, yeah. So the integral from 4 to 6 gave us 3, but the negative left over, we got to keep track of that, so negative 3. If I want to find h prime of 4, that means I have to find h prime of x. To find h prime of x, I need to find the derivative of this expression, which the theorems that remind you of. Second theorem, right? So we want to find the derivative of this mess. We know that those operations will cancel each other out. We can just plug the upper bound into the t and multiply by the upper bound's derivative. So nothing's gonna change because it's just really times 1. But that's what second theorem is, right? We wipe this out, plug the upper bound into the function, and then multiply by the upper bound's derivative. So h prime is simply just j of x. So h prime of 4 is just j of 4. So this tells us basically that the j graph is h prime, right? The j graph is the derivative of h. Or the j graph is basically the h is, yeah, it's basically the h prime graph. So what's j of 4? So we look at j of 4. J of 4 is just equal to 0. Okay, next page. Okay, part E, on what interval is H increasing and concave down? So we already know that H prime is J, right? Discover that H prime is just J of X. So this is the derivative of H. So remember, if we're looking at a derivative graph, we're going to gather information how we interpreted derivative graphs, right? We pull, so this is the H prime graph. I'm going to label my information for my derivative graph. Anything above the x-axis is indicating where my original J graph is rising. Anything below the x-axis indicates wherever my J graph is falling. Anything on the x-axis is where my J graph is experiencing a slope 0. So why don't we, oh, and then concavity. Concavity deals with points of inflection are the peaks and valleys of the derivative graph, and the rise and fall will match with the concave up and concave down of the original H graph. So let's build out our slope sine line. So this is from first semester, right? First semester review here. So I'm gonna create my sine line here from 0 to 6. So what critical points can we pull for our H prime graph? Not one. Okay, so x-intercepts, right? Where am I going to have slope zeros here? Yeah, 1.5 and 4. Yeah. All right, the peaks and valleys is something else. That we can use that when we build our second derivative sine line. Right. Don't look at the rise and fall of the graph. Look at where the graph is located. Is it above or below the x-axis? Above means positive slope. Below means negative slope. So where's the H prime graph located between 0 and 1.5?
Above.
Above. So that's going to translate to positive slope. Okay. Between 1.5 and 4. Below. Right. All this is below. And from 4 to 6. Above. Yeah. Okay, let's create our second derivative sine line. Also the same endpoints. But now, where are the points of inflection, which is the critical points for our H prime graph, H double prime graph? Yeah, peaks and valleys, right? So what points, what X values would you say? 1, 3, and 5. Yeah. So now let's build concavity information. What's happening between 0 and 1? Positive slope represents concave up. Don't look at the curvature of the graph. This is not the original H graph. So to pull concavity, we're going to look at the slope. So positive slope is concave up. Between 1 and 3. 3 to 5. Yeah. All right, so now it's a lot easier to answer the question, right? On what interval is our graph increasing and concave down at the same time? What would you say? Yeah, let's see, increasing and concave down. About 1 to 1.5? That interval there, where else? 5 to 6. Part F, find the absolute max, the absolute min, absolute max of H. So what does that remind you of? EVT, right? So extreme value theorem. And so what do we consider if we want to find what candidates do we want to use for EV2? Endpoints and yeah, relative max, relative min, yeah. And where can we pull endpoints and relative max, relative min from? What's an easy place to find them? Which one? First derivative. Yeah, this is all we need. Everything that we need is here. Don't look at your concavity sign line. Concavity tells you where the curvature changes, but it's not going to give you the peaks and valleys that we need. So we're going to use all these points, right? Because you got a relative max, you got a relative min, you got the endpoints. So we're going to find h of 0, h of 1.5, h of 4, h of 6. And then to find h, we can just basically total up the area under my J graph. And so we'll find h of 0 first. So h of 0, you look at the definition. Definition has the 0 up in the upper bound, so that's where we need to start. And then if we need to adjust, we can adjust later. But make sure you always follow the definition before you think about adjusting. So now that I have what the definition tells me, now what can we do? Yeah, flip and switch so that we can read the graph from left to right. Yeah, we only care about switching it if we're trying to read the graph. If we're just doing first theorem, just trying to evaluate or if we're doing the calculus with this, there's no need to flip the bounds. But if I'm trying to read the graph, typically we like to read from left to right. Okay, so we need all these areas, right? So let's go ahead and make sure we're looking in the right place. We only care about the region between the graph and the x-axis. So this one, all these are triangles, 1/2 base times height. So here, the base is 1.5, the height is 1. So we have 1/2, 1.5 times 1. That's going to get us down to 3/4 or 0.75. And where we found this to be 3, right? We found it on the earlier page. This one here, 1/2 base times height. So this is 2.5 is the base times 1/2 times 3. So it's going to get us 3.75, but it's below the x-axis, so this should be what? Negative. Okay, so we have a positive 0.75, a negative 3.75, a positive 3, and we're just going to put them in their right place there. So 0.75 minus 3.75 plus 3. All the meanwhile, I want to make sure I keep track of the negative. That's part of it. So I'm going to add that up and change the sign of whatever I get. It ends up just being 0. H of 1.5. Definition says from 6 to 1.5. Change the bounds. So this is negative 3.75 plus 3. H of 4. We found h of 4 from the previous page, right? H of 4 is just -3. Okay, what's nice about h of 6? Just 0, right? My upper and lower bounds are the same number, so that's always going to total to be 0. So between these three, what's the highest number, highest y value? Yeah, so absolute max value is 0.75, absolute min value is -3. That's it. Okay, last part. Part G, evaluate the second derivative of 2x from 2 to 3, from 1 to 3. Let me remind us of first theorem here. So I want to do a version of this to see if we remember. If I have integral from a to b of f prime of x, what will that turn into? F prime will become what? What's one level above f prime?
Over.
Hmm?
Over.
That's one below. What's
Oh.
above f prime?
Ethics.
Yeah, so antiderivative, f prime is going to rise up to f, and then we do f of what? B minus f of a, right? So the antiderivative is going to take whatever you have and make it go up one level, right? Derivative will make it go down one level, but integral will make it go up one level. So what if we are at the f double prime level? What's that going to turn into? Good, f prime of b minus f prime of a. So that's what we're going to do here. We're going to make that f double prime rise up to f prime. But before we do that, we've got to deal with that 2x. So this is in function notation, but guess what we have to do here? It's a function within a function. Use substitution. Yeah. So if it was if we're trying to find the derivative, we would go through chain rule. But the antiderivative, function within a function, we use substitution. So our u value is 2x. Derivative is what? 2. Okay. Solve for dx. So 2 dx equals du. Cross multiply, and dx equals du over 2. So we know there's a 1/2 left over in front. Let's get everything in terms of u here. So the integral f double prime of u du with the 1/2 in front. Well, it's du over 2, sorry. And then from there, replacing the 2x with u, replacing dx with u over 2, I can pull the 1/2 out in front. I don't want to deal with the bounds just yet because the bounds is not quite matching up with my variable yet. So what do we say? F double prime becomes what? F prime, right? And now I can replace the u back with what? 2x. Now I can plug in my bounds. 1 and 3. I didn't want to do it at this level because this is u, this is x. So I want to bring that x back into my antiderivative, and then I can work in the 1 and 3. Okay, what do I plug in first? Yeah, upper bound first, right? Upper bound gets inserted minus lower bound. So we get 1/2 f prime of what? 6 minus 1/2 f prime of 2. All right. Can I find f prime of 6? What's f prime of 6? Yeah. And f prime of 2 is 3. Yeah. Two, sorry. So this is giving you a taste as to what the quiz next Tuesday or the FRQ will look like. We're just going to practice through these types of problems. All right, so your homework, we did 7 and 8. You guys will try to finish 9 and 10 for me to check tomorrow morning. All right, get into the months. Okay, great. Thanks. Thank you.
In the middle of the patch.
Here's a chance.
Good, how are you?
I couldn't. Like my fingers and my fingers turned off. And the fuse are lost. I don't know.
I mean, they're definitely trying to
So I turned the flash
Around
on
and
everyone driving
pour
around.
it back with.
I just tried and I was trying to turn it back on. And then all of a
Yeah, I
sudden it
think, okay,
started.
Like Keenan Allen.
Then it started, so then I got this.
Let's see.
It's going on your car.
Bills, we get us start. Get trapped from being secondary players.
And everyone just drove around me.
Because our secondary is kind of depleted right now.
Place got places.
What does your brother think about Felix?
I think he knew. I think he knew it was gonna happen. I think he's okay with it.
Which is.
You'd rather have that number take it.
Yeah.
It's all turned
Oh,
off.
like,
They're cheap too.
Yeah.
I like.
Russell Wilson was like 1 year, 1 million or something.
Yeah.
It's like,
Oh, is your battery down? But
Bills.
Then
But I
the
didn't gas.
Bears will get a 4th round pick if Fields can play 51% of the. snaps.
I think Russell Wilson's gonna start.
He's gonna start, but then the hope is that Fields will eventually take over.
Yeah.
We'll see.
I don't know if Sears are gonna do that. I don't know. I have Fields to back up. I don't know.
Yeah,
I think so.
but there's no monetary incentive to start Wilson. They're both getting paid around the same.
Yeah. Maybe Pittsburgh's trying to have him like just like as like a learning opportunity. Just
That's true, yeah. That's true. I think it's good to learn from experienced.
Just happy we have Josh Allen.
Huh?
Just happy we have Josh Allen.
No gas.
Hopefully he's getting better.
It's like, where's Pickett gonna go?
He's on the Eagles.
He's back up.
Yeah, back. That's definitely back.
it's like 4 gas stations away.
Yeah.
Or.
The Bills win all the playing.
I know where you're.
Oh, the Bills win all the playing.
That's the worst part.
Next year could be the year.
It's like, we lost a lot of our defense.
It needs to be so that, well, Josh Allen's in his prime.
Yeah, we need. That's part of the reason why we don't release all those players to invest more in defense. We'll have a lot of money next offseason too.
Oh, yeah.